Good morning, guys. Welcome to mathspays.com. We're looking at IB Math Studies, looking at notation exam questions. So these are from 2013, 2012, if I remember correctly. Okay, so the first thing I'm going to look at is just a quick review of what these symbols actually mean. So we have our N, which is our natural numbers. Now remember, our natural numbers are our counting numbers, 0, 1, 2, 3, etc. So they're whole numbers starting from 0. We have our Q, okay, which refers to our rational numbers. So remember, they're numbers that can be written as a fraction. So things like 0.3, 5 tenths, 4, they're all rational. Basically, they're not irrational. And then we have our R here, which are our real numbers, which are basically any numbers that can be placed on the number line. Now remember, the one thing that isn't here, of course, would be our Z, okay, and our Z would refer to our integers, but that's not a question here. So what have we got here? We're looking at the numbers 3, -5, √7, 2 to the power of -3, and 1.75. And it's asked us to complete the table below to place a tick in each of these number sets in which it belongs to, worth 6 marks here. So they've done the 3 there for us. It is a counting number, it is a rational number, and of course it's a real number. All of these you can see here, they all sit on our number line. They're all real numbers, so we can actually tick our real numbers there. Now, in terms of them being rational, well, -5 is a rational number because it can be -5/1. We've got √7, that is not a rational number. Okay, that's irrational because we can't put it as a fraction. 2/3 is 1/8, so that is rational. And 1.75, well, we can put that over 100, thereabouts. That is certainly a rational number. And are they counting numbers? No, -5 is not, √7 is not, 2 to the power of -3 is not, and 1.75 is not. So I'm actually going to put little crosses just so you can see here. So a cross for the rest of them, but obviously we can just leave those as blank. Okay, hopefully that made a little bit of sense. Let's go on to the next question. Remember, you can certainly pause these questions and you can have a quick crack at it, and then you can do it yourself and see how you went. Okay, so consider the numbers 5200 and 0.5037. We want to write down the value of R if it equals to C times D. So all this really means is I'm going to be putting this into my calculator. I might use the white here. So for A, we're doing our 5200, and we're multiplying that by 0. And I said there were 5 of those zeros and 3 7, and that's going to equal to what my R value is. So if I check the calculator, press equals, we get 0.01924. So it says write down the value of R. We have done that. That's our first part of the question. Okay, part B, it says write down the value of R in the form of A times 10 to the power of K, where A is between 1 and 10 and equal to 1 and 10, and K is an element that is an integer. Okay, so it's got to be a positive number for our power, of course. So first of all, I'm going to put in here, well, I'm going to put a number between 1 and 10 because that's what it states. It does state it has to be between 1 and 10. So I'm going to put 1.924 times 10 to the power of. Now, our K value must be an integer. So how many times have I moved it? 2 times to the negative side because it's a small number. So 1.924 times 10 to the -2. That's the same as scientific notation, I guess. But certainly that is our answer for part B. Okay, then we move into C now. Consider the following statements about C, D, and R. Okay, I'm going to put down again here that C is equal to 5200. We know that D is equal to 0.50 and then 37. We've got our R value here is 0.01924. So it says circle the true statements. All right. So again, this brings back to our previous question about what N, Z, Q, and R is equal to, etc. So here it's saying that C, 5200, is a natural number. Well, that is correct. It is a counting number. So I'm going to count that one there. It says only 3 of these are true. So we got the first one. The second one says that D, 0.5037, is an integer. Well, that is not correct because it is not a positive, negative, whole number, or zero. It says D is an element of a rational number. Well, that is correct because I can hit the fraction button, and although it's going to be a very, very small fraction, okay, that certainly will be a fraction. I have to do one more, sorry. R is less than D. Well, R is certainly not less than D. It is bigger than D. Looking at our place values, that one there is bigger than a 0. C plus D. So if I add these together, so C plus D, we get 5200.12345537, okay, is going to be a real number. Well, that is correct because that does sit on our number line. And then just to double check to make sure that we have got the right 3, it says 1 over R, so 1 over 0.01924 is greater than C. Well, C is 5200. And all I need to do now is put in my calculator 1 over, or 1 divided by 0.1924. That gets me 51.975, ellipsis, and then greater than 5200, which obviously is not correct. So that's not right. So there my 3 are correct. Hopefully you got those ones as well. Okay, our last question once again, folks. Make sure you pause this, have a bit of a crack at it, see how you go, and then obviously press play. Okay, so it says our universal set, okay, our generalized set, I guess, for all x, such that x is an integer and it sits in between 2 and 10. Okay, so we know what our universal set is. So I guess a universal set, what we're looking at are numbers such as 3, 4, 5, 6, 7, 8, 9, and 10. Oh, not 10, sorry, my apologies. Let me get rid of that last number there because it's less than 10. Okay, and looking at first part of the question, it's actually saying to list all the elements of U. So in fact, I'm going to put that as my first answer for U. They are all the different elements. They sit in between 2 and 10, and it's an integer. For part 2, and again, this is for A, we've got list the elements of B. Well, A and B are subsets of U. Now remember, a subset means that they are some of these numbers here. Well, it could all be all of them as well because it doesn't say at the moment that it's a proper subset. Such that A has multiples of 3. So we're talking about things like 3, 6, and 9, and we have B are the factors of 24. So usually we would have 1 and 24, but obviously we can't count those because we're going between 2 and 10. So what we're looking for B, okay, we're looking for numbers such as 3, because 3 times 8 is 24, so 3 and 8 will work out. We've got 4 and 6, and they're both numbers up there, as you can see. They make 24, but I can't go any higher because 12 and 2 don't work because they're not in our universal set. So for our B, we've just got 3, 4, 6, and 8. Okay, going into part B. Now I know I haven't done anything on our Venn diagrams. Hopefully you will remember these though from previous years. It says write down the elements of U on the Venn diagram. Okay, remember U is a universal. We've got our A and we've got B. All right, so what we're going to put here, we might put for A, we've got our 3, 6, and 9. Now, noticing that 3, I'm going to put that in white, sorry. 3 goes into both. 4 goes into, apologies, I'll just reverse that because that was U, not A. My apologies. We've got A underneath. I'm going to put that as 3, 6, and 9. So, sorry, 3 goes into both, as I said. We've got 6 goes into both. So, what I'm going to start off by doing is I'm going to put 3 and 6 sitting in between because that's in both A and B. Now, for B, we've got 4 and we've got 8. For A, we've got 9 left over, which means for our universal numbers, we've got, so we've got 3, 4, we've got 5, 6, we've got 7, 8, and 9. So that works out for the rest of my numbers. So we've written down all the elements of U, so that's all our numbers, but we've placed them into the correct orders for just A and B, and just B. And it says there, write down how many numbers there are for A and B. Well, for A and B, okay, we only have 2 numbers that go into both. Remember our terminology, we have that is our N or our AND, which we refer to as the intersection, okay, as opposed, of course, to our union, which is the OR. Okay, so look, that's our third question. Hopefully that gives you a little bit of information about notation style questions for our set notation. Again, they are actual IB questions for mathematical studies. Any questions, guys, drop me an email or drop me a message via YouTube. Have an awesome day, guys. Hope that was useful to you. I'll see you later on.